In this video, we're going to discuss medians and altitudes of triangle and their points of concurrency. So, first of all, a median of a triangle. It's a segment whose endpoints are a vertex and the midpoint of the side opposite that vertex. So we're using the vertex C, and opposite C would be the side AB. D is the midpoint of the side AB, and so connecting the points C and D, we get a median. Every triangle has 3 medians from each of the 3 vertices. And the medians are concurrent at point P we see in this diagram. That's where these 3 medians intersect, and so that is where they are concurrent. The point of concurrency has a name, and it's called the centroid. Now, the centroid's located 2/3 of the distance from a vertex to the midpoint of the opposite side, meaning it's 2/3 of the median. Well, it's kind of difficult. Let's look at that again and say, well, this CP, and I highlighted it, there's a longer portion here from C to P. This portion is 2/3 of the entire median. So if I knew the length of CD, I could multiply that by 2/3 and find the length of CP. Now, it also means that the smaller portion would have to be 1/3, because that would make the whole thing 2/3 for the longer portion and 1/3 for the shorter portion. And so DP, as we highlighted in green, is 1/3 of the median. So essentially, the median is divided into 2 portions by the centroid. There's a longer portion and there's a shorter portion. And the longer portion is 2/3 of the median, and the shorter portion is 1/3 of the median. That also means that if we look at the ratio of the longer portion to the shorter portion, it would be 2/3 to 1/3, which is a ratio of 2 to 1. That's also saying that the longer portion is twice as long as the shorter portion. Well, let's look at how we can use this in a problem. So here's our example. We have this triangle, and we have the 3 medians drawn in it, and we're given some measurements. We're given that CP, the longer portion of the median CD, is 5.4. We're given that the length of JP, the shorter portion of the median AJ, is 4.7. And BH, the entire median, the 3rd median, is 12.6. What we're going to find out is CD, AP, and HP, and I highlighted those in yellow in the diagram, so it'll be easier to tell when we get there. For CD, since we have the longer portion, we're going to use the formula C. The length of the longer portion is 2/3 of the entire median. We use substitution and plug in what we know. And now we need to get rid of that 2/3 times CD, so we will multiply by the reciprocal. And using our calculator to simplify, we get that the length of the CD is 8.1. For part 2, for the length of AP, we remember that the ratio of the longer to the shorter is 2 to 1, which means, like we said earlier, the longer portion is twice as long as the shorter portion. So we have the formula, AP is equal to 2 times the length of JP. Substitute in what we know, and then simplify. And we get the length of AP is 9.4. And for the last thing we had to calculate in this problem, we're trying to find HP, the shorter portion. And so we're going to use the formula that the shorter portion is equal to 1/3 of the entire median. Using substitution with what was given to us, and then using our calculator to simplify, or you could do it with pencil and paper, we simplify and we get that the length of HP is 4.2. So this is how we use this centroid in calculation problems with triangles. Now this next part is the concept of altitudes. So an altitude of a triangle, which we've drawn here in triangle LMN, is the perpendicular segment from a vertex to the line containing the opposite side. And this is important, the line containing, and we'll see that in a little bit when we see another example. But right now we can see that we have this altitude that is from point M to point P, and that segment MP is perpendicular to LN. This is different than a perpendicular bisector. This perpendicular does not necessarily bisect the side LN. It is just perpendicular but goes through the point M. Now, every triangle has 3 altitudes. The altitudes are concurrent, and here we have it at point T. The point of concurrency is called the orthocenter. Another term for perpendicular is orthogonal, and that's where this comes from. The orthocenter is from the concurrency of the orthogonal lines. Now, in an acute triangle, like the one that we started off with triangle LMN, all the altitudes are interior to the triangle, so therefore the orthocenter is interior. And there's the orthocenter. But in a right triangle, the legs, not the hypotenuse, but the 2 legs, are 2 of the altitudes. And so the orthocenter ends up being the vertex of the right angle. So here we have triangle ABC, which is a right triangle. I've drawn in one of the altitudes, and when we highlight the 2 legs, we see that they all intersect at point C, which is the orthocenter. Also, that is the vertex of the right angle of the right triangle. And the third case is in an obtuse triangle. 2 of the altitudes will be exterior to the triangle. And because of that, the orthocenter, where they all will meet, will have to be exterior as well. So here's our obtuse triangle, triangle XYZ, and we've got the segment YW, which is one of the altitudes, and it's interior, the whole altitude there. But we can't draw an altitude from the point Z to the side XY without doing something else. We must extend the side of that triangle. And so when we extend the sides of the triangle, then we're able to construct that perpendicular to that side. And this is like we highlighted up above, up here, where we highlighted the line containing the opposite side. It doesn't actually intersect the opposite side, but it is perpendicular to the line containing the opposite side. And we draw the other altitude, and we can extend the first one that we did, and note that they all intersect at this point, which is the orthocenter. We're not going to do any calculations at this time with altitudes. It's a concept that we need to know. It's an important term that will be the vocabulary you'll be tested on and quizzed on. So this is very important. It's just that we aren't going to do any calculations with it at this time.